My fun fact now. Okay, good. So, now it is. So last summer, I helped my friend Julia to move out from her apartment. That is me, with a ton of sunscreen on my face, in order to not become a lobster. So right after that, and after painting the walls of her apartment, I went home, I touched up my makeup, and I drove my electric car to the pub to claim my reward, a very cold beer with my friends. All of the items that we had very things similar. From the sunscreen, to the paint, to the makeup, and to the batteries of my car, all of them are made of the same thing. They are made of really fine powders called nanomaterials. And mixed together in the right proportion with another components, they gave us many different products. But the important part here is that we want to make sure that these nanomaterials are in the best conditions by the time we want to use them. I do not want to become a lobster if the nanomaterials inside of my sunscreen are damaged by the time I put it in my face. And that is what my research is about. I explore a new way to create and keep nanomaterials in their optimal conditions until we want to use them. But how do I do that? Well, when I was helping my friend Julia to move, we would wrap her important stuff or delicate stuff with another materials, such as bubble wrapping paper, hoping that the magic of the bubbles could take the heat if an accident happened. Like the bubble wrapping paper, I use a similar concept in my research. In order to keep our precious nanomaterials safe, I wrap them with another nanomaterials, so those are the ones that take the heat. Imagine an almond M&M, which, by the way, is my favorite kind of M&M. An almond M&M is an almond covered in chocolate. I like to think of it as if I create very tiny almonds in the lab that can be made out of different materials, such as titanium dioxide, and then I cover them in chocolate, such as silica. The idea behind it is that the chocolate silica will be the one taking the heat, keeping the almonds in their perfect conditions until we want to use them, in this case, to eat them. So, in order to create these special M&Ms, also named coated nanomaterials, we use a metallic box. This metallic box is named reactor. And if we look inside of our reactor, we have a flame. And in order to produce different nanomaterials, we have to put something into the flame. So depending on what we put into the flame, we will create one sort of almonds or another sort of almonds. In this case, we will be creating titanium dioxide almonds, as titanium dioxide is a nanomaterial present in our paints, sunscreens, and makeups. In our reactor, we also have the chocolate spray. In other words, silica precursor spray. And when our almonds pass through these sprays, they get coated. And after getting coated, they move along in the reactor, and we collect them at the end as chocolate-coated almonds. When I collect them at the end of the reactor, they look like this, a white powder. It looked like a normal white powder, really. But if we check under a very powerful microscope, like this one, we saw something that we actually did not expect, this. We saw that there was a huge amount of chocolate silica, which is the dotted thing, covering a lot of different titanium dioxide almonds, which are the circles with the stripes on them. And that is not what we wanted. We wanted individual M&Ms. So I thought, well, that was only the first experiment where I put more amount of chocolate than almonds. So let's change the recipe. Maybe that will make the trick. So instead of putting more amount of chocolate than almonds, I'll put the same amount of chocolate than almonds and see if that gives us our individual M&Ms. So I went back to the lab, I created my almonds, I coated them, and then I collect them at the end of my reactor. And what I got at the end was this, a white powder looking identical as the powder that I got in my first experiment. But again, when I brought this under the microscope, I saw that we got our ideal M&Ms, which was great news. Therefore, our conclusion was that in order to have our individual M&Ms as a success, we need to keep the same amount of almonds and chocolate. In other words, the same amount of silicon to titanium. Creating these special coated nanomaterials, or M&Ms, happens continuously. So we create the almonds, we coat them, and then we collect them at the end of the reactor. So since that happens continuously, it has a huge potential for scalability and mass production. And that is because we can produce M&Ms non-stop. So this is only the first very steps out of a list of experiments that we want to explore. We want to create different nanomaterials and see which is the coating that works best and which ones create our M&Ms. We also want to play with different parameters of the recipe and see how the outcome changes between that. Because basically what we want to do is create different color of M&Ms and see which ones are better to keep our materials longer. So our sunscreens, paints, makeup, and batteries are better, long-lasting, and cheaper by the time we want to use them. Because as Forrest Gump would say, life is like a box of chocolates. You never know what you're going to get, unless you're like me, and you look at them under a microscope. Thank you very much.